Hello, everyone. Welcome back. Today's video is on the rock cycle. The learning outcomes of today's video is to describe sediments, sedimentary rocks, igneous rocks, and metamorphic rocks. We're going to identify locations where these rocks form in the environment, and then we're going to evaluate the term the rock cycle. So the rock cycle describes the process in which rocks and matter moves through the environment over many, many millennia. So it's sort of this formation and reformation of matter into different types of rocks. You have igneous rocks, which are formed from the solidification of liquid rock, of magma, lava, weathered rock turns into sediments, which eventually solidify into sedimentary rocks, and those are repressurized and heated to turn into metamorphic rocks, and that cycle just keeps on churning, and it's sort of the reuse of matter. We're going to cover a lot of cycles in this course because nothing in the environment is waste. It's always the input of a new process. So you always come across cycles of matter in the environment. To kick us off here, the one you may be most familiar with is sediment, which is just sort of the sand at the beach or in a riverbed. Soil is made up of sediments, but soil is sediment that includes organic matter as well. But sediments in this case is broken down bits of stuff that's typically rock, but it can be entire mineral fragments. It can be organic matter like shells and bones. If you find broken down seashells at the beach, that has become a sediment now. And something to think about is plastic is now a sediment. And throughout this lecture, you can think about how plastic will show its head in different parts of the rock cycle many millennia down the line, because it's this new matter thing that we've introduced into the environment. And so how will that show in geology in hundreds of thousands of years? So how does sediment become a sedimentary rock? Well, it's through a process of cementation and compaction. So whatever the sediment was before, it's still that main clastic body is still preserved, but it's now stuck together in a rock. So sediment is not a rock, but now it's been stuck together, and that's created a solid mass, which we would call a rock. And this process is called lithification, and it's a combination of both compaction, where we're reducing the volume which the sediment is taking up. So if you have your beach and you're pressing it down really hard, you're going to solidify that even more and increase the contact points between each sediment grain. And then you have water that pours through the sediment. It deposits different mineral deposits like halite, which we discussed, calcite, and hematite are common cementation materials, and those eventually form the solid sedimentary rock in the end. That entire process is called lithification. And so a metamorphic rock is a slightly changed version of another type of rock. So it's a rock that's undergone a physical or chemical change. And this is done either by pressure or heat or both. And the extent to which that a change has occurred, the amount of pressure that's been applied, the amount of heat that's been applied will create a more dissimilar rock. If I apply a lot of heat and pressure to, let's say, shale, it's going to turn into something that looks a lot more like granite than the original shale. If I just add a little pressure and heat, it's going to remain something closer to what I started out with. So a sedimentary rock can become a metamorphic rock through a process of physical and chemical transformation. And one thing I want you to ask yourself is, how is this pressure and heat being applied? Remember that rocks can't move. So how have we moved this rock from a place where it wasn't receiving pressure and heat to form into a sedimentary rock, to now undergoing this transformation? And the answer to that question is usually tectonic activity or an intrusion of magma. The movement of magma and lava can also produce metamorphism. And finally, how does a metamorphic rock become an igneous rock? And that's by melting. You take a sedimentary rock and you apply too much heat and pressure, you'll shoot past metamorphism and just turn it into a liquid rock again, which then solidifies and becomes an igneous rock. Igneous means from fire, and so igneous rocks are any rocks that are produced from liquid matter, from liquid rock. And then eventually surface processes will weather the igneous rock and return it to sediment, and we've completed our full cycle. So what's missing? Could an igneous rock become a metamorphic rock without first becoming a sediment? Of course, yeah. So this term, the rock cycle, is a lot more complicated than just a complete spin around the wheel. We can cut through and move directly from a sedimentary rock back to a sediment, to a sedimentary rock, back to a sediment. We can just keep doing that cycle. We can go from sedimentary rocks to metamorphic rocks that then become sediments. You can have metamorphic rocks or igneous rocks that become metamorphosized and change through heat and pressure. They just need to go through these agents of change to be classified as this new type of rock, but it doesn't need to happen sequentially. Things can cut the circle. So the rock cycle is a bit more complex than just a big circle. In summary of this video, we've described the major processes that form and reform rocks. All rocks sort of start out as magma and lava. They crystallize into igneous rocks, which weather into sediment. These sediments lithify into sedimentary rocks, and then sedimentary rocks change into metamorphic rocks with heat and pressure. And here's a picture of where those things are located relative to sort of a plate boundary. So here we have a mid-ocean ridge, which is home to a lot of volcanic activity. This is where most of the Earth is created. About 99% of Earth is created at these mid-ocean ridges. And so this is exactly where you would expect an igneous rock to form. You can also expect them to form on volcanoes at volcanic sites. We have a tectonic boundary here, which we will discuss more in our next chapter. But at these tectonic boundaries, you are subducting matter into the earth. So this tectonic activity is how we're moving rocks. We're moving the crust down closer to the earth, exposing it to heat, sending it down. It will also expose it to more pressure. And so you're getting metamorphism along the subducting crust. And that's where metamorphic activity is happening. And then weather and erosion just happens anywhere that rock is exposed to air and to the environment. Sedimentary rocks commonly form in the ocean as things are deposited on top of each other as well. But that can also happen on the other side in more terrestrial environments. Anything where sediment can collect and then you get meters and meters high of sediment, those will compact and turn into rocks. So these are the locations at which those happen. And that concludes our lecture. If you have any questions for me, please don't hesitate to reach out to me on Canvas. Take care.